Ba 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 da ba. All right. Ba, 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 ba. Hello, 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 hello. Okay, let's see how review. Damn, 4 viewers already. What am I gonna do? Okay, whatever. What's this? Yay, multicore OCaml. Cool. So how the hell do we multicore? So multicore OCaml. Start here. Parallel programmer in multicore OCaml. This is not that old. Domains. I remember this library from before. You can spawn domains. Then we join them. Earn. Ooh, I like this. More guides. Guides. Transitioning to multicore with Tsan. Ooh, listen to that. Alright, so 5.0. I'm on 5.0. That should be fine. Great. Nice. Good reference to the oxidizing post data race freedom. Exclusively mutable. Sync. Nice. Okay, so I won't be able to run Tsan, but that's fine because I'm writing an application from scratch here. See the little bank library with following signature. Write a parallel test runner. Okay. Cool. So what I'm picking up from here is that we're going to be using domains, right, to actually spawn parallel workloads, right? I don't know yet if what they mean here by parallel is actually effectively parallel or if it's going to be more of an beam style parallel, right, which could be concurrent but could also be parallel depending on how many cores you're running. My phone is doing this thing. I don't know why. All right. So it does look like the domains library would be a good one to have. Nope. I want to go to OCaml docs domain. Alright, this is unstable, no problem. API version 5.1. Can I see the docs for version 5? Maybe we could just move to switch list available to 5.1. I think there was a release, right? Recently. 5.1 official release, yeah. Base compiler 5.1. Okay, OCaml switch create 0.510. Cool. So we get spawn to create a new domain that runs in parallel with the current domain. We get this raises a failure if the program has insufficient resources. Cool. All right. I don't know what I would do with that failure, but I guess it's an exception, so we just crash there. And joining will block until domain D runs to completion. Okay. So my first thoughts here are we have some very low level primitives, right, to spinning up work and just letting it do its thing. It does feel a little more like a thread pool, so we'd create a couple of these domains and we'll have them running, but I don't really know how lightweight the domains are, so maybe we'll have a look at the parallel programming chapter in the manual to see if there's any references to that. And I think the music is a little loud. I don't know, it's a little loud on my end at least. And then maybe we'll do a test and see how many of those domains we can spin up. Ooh, there's DSL here. No, DLS. That's a different thing. Domain local storage. Huh. So we can create keys, and the keys are typed. What's this for? Okay. Interesting. Domain local variables. All right, let's go one level up. We're gonna go into the manual. Actually, no, this is not the manual. OCaml manual. Yeah. Parallel. Nope, I don't want to print. I want to search. Come on, browser, keep up. Parallel programming. Ooh, brilliant. So we're just gonna run that here, and I think we're gonna have to do that there, and at the very least install Dune. In this chapter, we'll look at parallel programming facilities in OCaml, exposes the low-level primitives for parallel programming, and recommendations to use it. Okay, so domain sleeve is higher level library that we have here that we can use for this. And I've seen this before, because fun fact, I think, what was it, the channel, let's see, channel interface, make bounded. Yeah, I think this channel interface was almost the same as the process type interface I came up with for OCaml back in the day. Since in OCaml you'll actually be running Erlang and you want to spin up processes, right? And you want to be able to say, oh, this process can take these specific kinds of messages, right? So you, instead of type of channel, you would have type of a process, like message, right? And then process. Cool. All right. So we have tasks, multi-channel function queue. What's this? Functional queue. All right. Read me. Nested parallel programmer. I wait mechanism for spawning parallel tasks and waiting the results. I actually would like to avoid that. Async await. Which is one of the reasons I want to see how heavy the domains are themselves. Like, can I treat them as like green threads or Erlang style processes? So if I can do that, then I can just like pause them, right? When they're doing that, or just have them block, and it will be okay. but maybe it does not. Maybe it doesn't work that way. Okay, so we set up a pool, and T is the task, so we need to go into tasks to see what the hell the pool is. We use a new pool, will be empty. When an empty pool is in use, every function in this module will run effectively sequentially, using the column domain as the only available domain. Okay. So I guess this manages domains for me. Lookup pool, run. Sync. Okay. It seems like the idiomatic way here would be to say I have some work, right? Just like open a buffer. So I have, let's say, top level URL or root URL, right? And I can fetch and sort of extract links from here. And now I have a collection of URLs, right? That I need to do the same thing on. It seems like the idiomatic thing here will be to set up a pool, right? And maybe we will have the amount of domains equals to the number of CPUs. Yeah, domains leave is a work still in queue. Yeah. So it feels like a domain is kind of like a thread, OS thread. So we would set up a pool of domains, and then we would queue up this root URL for some work to happen. And then when that URL comes back with a bunch of more URLs, we will just queue those URLs into the pool. And that way we would manage to use these domains to execute OCaml code in parallel. There are more example programs here. Let's see. Ooh. Parallel find. Let's see that. So we get needles, input, length. Damn. Coffee's not working this morning. Oh, we got a parallel find already there. So this I is gonna be the start and the finish. Okay, this is like an iteration over that range. Let's see. Task parallel find. Get pool data. So we have some atomic operations here. Found. Okay. Unnamed math that does something, gives us a chunk size based on the length of the domains. Max 1. Okay. And then we have a recursive function for the work. And we're using this atomic to synchronize the threads. So S start and end, right? Start, finish, yeah, okay. As long as we're still within the range of the chunk size, so the end minus the start is less than the chunk size, then we will build a reference to the starting point, right? Which we assume we will modify sometime. Good morning, folks. Hey, Eddie. It's been a while. I think I did reasonable coding stream back in 2019, I want to say, about Pony. Reasonable coding, Pony, concurrency. Yeah, exploring the actor model in Pony. Holy crap, 4 years ago. I'm gonna mute that. Yeah, this was almost 4 hours of just going through everything that they have. They're writing some Pony code as well. A lot of errors though. Yeah. I like Pony. I thought it was interesting. I liked you know, I felt like if you came from OOP, it would have been an easy sort of segue into something like Erlang later on, except that, you know, Erlang doesn't have types in the same way that this does, where you create classes and stuff. I really like the capabilities model of being able to say like, hey, this is sort of something that I am allowing you to read or modify, or when you send it as a message. What I did not like is that, if I remember correctly, message passing is actually method calling. So it's message passing as in OOP, right? So this is, I think, closer to, I think, it's been a while, but I think it's closer to Smalltalk in how it executes than Erlang. But I don't remember, I don't know if current implementations of Smalltalk like Faro are sort of multi-core capable. Crits Creek, I don't know. I think one of the first programs I wrote in OCaml was maybe 2015, something like that. Maybe longer. I did a bunch of reason during this time. The reasonable coding. Let's see if I have the first video here. Pop-up videos. Yeah, I lost a couple of them, but some of these are from like 4 years ago when reason was the thing to be learning and doing. I dug into a bunch of libraries here. Many of these libraries are still relevant today, like LWT, for example. Stuff like our command liner is amazing. Yeah, I should probably rewatch some of this. The profiling one is definitely something I've been meaning to do lately in OCaml, and I forgot entirely how to do that. So it's a good thing I have some content here to go back to. Yeah. Anyways, I'll go back. I used Rescript in production as well. Last company I was working with, Walnut.io, they have a massive web client, right? Like a web application written in Rescript. Last I checked, it was like 300,000 lines of Rescript. I would not call myself an OCaml veteran. I've just seen a bunch of crap happening, but a lot has happened in the last like 7 years or so. Yeah, but I have not shipped as much like production OCaml code as, for example, Erlang. And regarding like Rescript not being as extended as TypeScript, I don't know. I kind of like that Rescript is limited. Let's say limited. I don't think it's the right word, but what kind of extensions would you like to see in Rescript, like compared to TypeScript? So so we're just using this reference here to be able to iterate, right? And as long as the iteration does not exceed the end, and as long as we haven't found what we wanted to find. So that's why we're using this found here. And it's atomic because multiple, I guess this work will be scheduled. Where is it? Like I'm still not seeing exactly where this particular work happens across many of the cores, right? But we're using the atomic to synchronize. All right, so we do a match on the function, whatever function we have here, and extract the current iteration value. Okay. And then we increment. And increment I guess incr is defined somewhere in here. All right, can't find it. Aha, here we go. So this async pool function, I think here's how we're scheduling the work. Let's see. Prescript because we do a PWA that has to run in vessels, ships and sea. Ooh, nice. So our app makes extensive use of IndexedDB to be able to work offline, and we do a script because to harden it, yeah, because if it fails, we get the telemetry hours later. Yeah, that makes sense. I wish the script had better type inference at compile time to have better macros. So the type inference, right, is really excellent, right? But you're not gonna get that at macro time. I think most languages, right? Okay, type reflection. I don't think you're gonna get type reflection either at macro time, right? Because the type checker just hasn't run at all. So like the best you could hope for at that point would be to say, okay, we're gonna give you all the annotations and all this stuff, right, for you to play around with. But then it's sort of up to you to make sure that you put together types or make derivations from those types that make sense. And I think that to some degree, the deriving macros do something like this. Recently, like a year ago, I was working on OCaml, like a port of the Cerde library from Rust into OCaml, and in the derivation code here, right, where I was building a macro that essentially works on the types, right? So we are registering the macro in the macro system, and then we have this implementation generator, right, that generates an implementation for a serializer based on the types. And when you look around here, right, you do get a bunch of information about the type, but all of this is syntactical, right? It's not, all of this happens before the type checker even runs. To be able to get that kind of information at macro time, we would sort of have to run the type checker, right? Like annotate the entire tree and give you the type tree to work with. I think that makes some sense. But I think it would also make programs rather slow because you have type check, run macros, and then type check again to make sure that whatever the hell the macro expanded to, right, it's still a valid program. And that might not be sort of justifiable to a lot of people. I do agree with you that the macros in OCaml, they kind of suck. Like, it is nice that they're so tight and sort of typed, and you have to write them with all of this just structure. I like that once they work, but once you're exploring a little bit how to write a macro and so on, it is very painful to write a PPX, right? I really wish we had something closer to the Rust procedural macro system where it's like, okay, here's a bunch of tokens, do as you wish with them, right? As long as you give us back a form, like a valid AST, right? We'll type check it from then on, but before that, you can do whatever the hell you want with these tokens. I really wish we had something like that. Yeah, that's definitely for another stream. I would like to play around prototyping something like that. I know a lot of people are not gonna like it because PPX comes out, right, of a process in which they restricted what kinds of macro systems you can or should want in OCaml, right? There's this whole camel for P, or 5P, I think, by now, library, preprocessor, pretty printer, right? Camel P5, sorry. And I forget where the documentation is for this thing. But it's an entirely different macro system, right, than PPX is, and it lets you do all sorts of weird and fascinating things, right? I don't know if we will be able to find some quickly. I have, as you can tell, I have not browsed the specific website before. Functional parsers, no. But they usually have this example. Well, I'm not finding it. Where they let you embed a different language within OCaml. And the problem this had was that, eventually end up with all the tiny little dialects of OCaml, right? That the tooling doesn't know how to handle. I'm not doing a good job representing why this was a good/bad idea to some people, right? But here's a repo, Camel P5. Go have fun with it. It's still maintained. I think the Chet Murthy, I don't know who they are, but they're definitely still at it. Yeah, it certainly has become the norm. I don't know what I'm looking for here. Anyways, all right, you can go have a look at this. I'm sure in the test suites you're gonna find some examples of how to extend the language, maybe in the tutorial, even. Okay, I'm done with that. Nope, I wanted that. Let's have a look. Reindexed. So what am I looking for here? I want to inspect type information on a type, because we do have a custom 30 in the script in this ORM for IndexedDB. The ORM is not documented, but look at example and test here if you want to hurt your eyes. All right, let's see. Hey, Vinny. Hello. So you make a general consumer for the vessel consumer, and this is coming from the patterns. You have an indexing and limit. Eddie, you have a specific example or something? Because this, so far, this looks all right. Like you're just making, a new module and then using that module. Yeah, white theme. I'm using, it's daylight here, so it's white. Crits Creek, I do not know what generic SOP from Haskell is. I have not used Haskell that much. Not in anger, at least. Of course, the documentation is a paper. Why am I not surprised? You gotta give it to Haskell people. This looks great, right? It's nice to look at. I'm not saying it's gonna be easy to read, but yeah. All the typesetting definitely pays off. We introduced some products view for data type generating programming in Haskell. Many of the libraries that are commonly in use today represent data types arbitrary combinations of binary sums. Sub reflects the structure of data types more faithfully. Each data type is a single n-ary sum, alright, where each component of the sum is a single n-ary product. Okay. This representation turns out to be expressible accurately in GHC with this. A major plus of Super is it allows to separate function-specific metadata from... I don't know. I don't... like, I get what it means, you know? Like, in OCaml, we can also do the same thing. We can say hello, and instead of just having a record, you can just have variants, right? So, hello, off, and then just put the record here. And this will be, if all types were like this, then you will have sums of products, right? The product being the record, the sum being the variant. But how does that result in macros? I don't know. Let's quickly go to the end conclusion. I presented a sub-library for generic programming with a precisely typed universe. We believe that library is easy to use for a wide range of applications. Those that require more global information for the shape of the online. Okay, and those that need additional application-specific metadata. Yeah. Well, we tried. Probably a good idea for smarter people than us. Me at least. I will make no comment of the smartness of anyone else. This is a 4K monitor. I think so, yeah. And Vinny, regarding the aesthetics of OCaml, honestly, I think after a while, you just forget about that. Like, I don't know, the lets, the ins, they sort of fade away, and you just see the code. I would admit, though, that this Y theme, I don't normally use it. I usually use it on my laptop, but I've been syncing my dot files, so they're the same. Let's see, if I go to system settings, if I go to dark mode, where am I here? I'm insert ML, cool. So normally this is what my terminal looks like, right? That is easy on my eyes. Oh well. There we go. I really like Rescript. I really like the syntax. It looks very polished. Reason not so much. It's just a personal preference. Okay, so I don't know what we're looking here, Eddie, but it seems like you are not answering. So I'll just move on. Cool. So we're back into on the little library we're writing, and I'm calling it Triple. Another Star Trek reference. Yeah, and the idiomatic way here will be to set up a pool of domains and then just like queue a URL, and then that URL will eventually queue more URLs and so on. And we were looking here at the parallel find, which was something we picked up from a test. I wish to learn to love OCaml with your stream today. Nice. I like that. Sheridan Chris. I hope I didn't butcher that. How easy would it be to transition from F sharp to OCaml? OCaml seems more appropriate for my needs. Truth be told, I haven't written F sharp. I've read F sharp code, but I haven't written any. I think there are some features like type providers and I want to say functional objects or stuff like that that we don't have a good or easy translation for in OCaml. So depending on how you're using F sharp, you'll find that there are some edges that are uncovered, right? Like, oh, we can't do this thing in OCaml. Or the solution we have is just very verbose or whatever. But there's a big overlap, right, between the two. I think that language-wise, that will be one thing. It should be pretty straightforward. Ecosystem-wise, however, I have no clue. It's been a long time since I've done anything on Microsoft's platforms, right? So I cannot tell you how hard it will be to think differently from whatever they're doing, right? And I also know that OCaml is growing, right? It has a lot of very specific libraries that are amazing. So if you're currently doing, I don't know, PLT or DevTools in F sharp, you might just find yourself at OCaml right at home. But if you're doing some other things like Windows programming, then maybe OCaml will be a little tougher to get into. Really? Is that because it's downscaling from 5K or something else? Gotcha. All right, so we were looking at the work function here, right? And we covered that while loop, which is sort of the thing that constantly checks whether we're done, right? Doing some work. And on every iteration, it runs the function that we tell it to. Which I guess, where the hell is that function coming from? It's called body, and body comes from here, parallel find. All right. So if we go back to the example we had, right, which was parallel find. In this case, parallel find will receive a body, which is this function that checks if the number I, which will be between start and finish, right, it's actually in the input array. And we started needles. Okay, so we started needles with 4 random integers, and then we start our input array, right, with this length, and then randomly we set true, I guess. Yeah. To those needles in the inputs array. Cool. Okay. Yeah, this arrow means assign. Sorry, I got distracted there. Someone is pinging me. What the hell? All right, back. Yeah, so we were still looking into part of, that was the body. The body just checks if the current number, right, is in the array. So if we go, actually, I'm just gonna open that in a separate tab. ML, cool. All right, we're done with that. We go here. So if we are done, right, iterating, so essentially the end, the finish line, and the starting point, right, And I think the starting point is going to be moving. We'll see that in a second. If this is not smaller than the chunk size, that means we actually have gone above or below. I think below. No, above the chunk size. So then we check. If we do have something already in the found atomic variable, then we just end. We stop. Because at the end, we're going to just return whatever is in found, right? And else, if we are not yet done, right? Where does this chunk size come from? Okay. All right, so chunk size is actually gonna be a number, right? That represents how many iterations this specific, let's say, version of this while loop needs to run, because we'll be running this in different chunks. Am I getting that right? So we do work, but we just schedule this once, right? Parallel find only calls work once, right? And then the first time it'll just go through, because start minus finish should be bigger than the chunk size, right? So the finish should be bigger. And then it will go in here, because we don't actually have anything in found yet, right? It's none. So we're computing here a delta, which is half the distance between the end and the start, right? And we're adding that to the start. I'm having a hard time seeing how this unrolls the work and sort of deploys it to each one of the cores that we have, the domains that we have, right? We do have a pool that we're passing in, and I guess that's sort of what's going to define how many instances of work we can have at any given point, right? If you have like 2 or 3 domains, then you get 2 or 3 sort of pieces of work happening parallelly. But it is not, I don't see it straightforward, such as like, hey, here's the pool, right? Run this function over this entire collection, right? And like maybe even in a loop, right? Just call async, right? N times for every one of the domains we have in the pool. Just to illustrate that, like we don't have something like pool, like for let's say domain in pool, right? Domain spawn, right? We don't have that. So it looks like we're actually queuing into the pool using async and await, right? So every iteration, as long as there is more work to be done, right, and we haven't found a result, we will use async to actually put into the pool this little chunk. Let's see. Chris Creek. My guess is not doing the splitting up front to distribute the work of splitting onto multiple threads as well. Well, I guess what I was hoping to find here was you spin up the workers, right? And then the workers actually steal work, right? From the queue. Something that was a little more upfront about how the, let's say, the topology, right, of the work, of the execution graph will look like. But here, I need to go deeper into the work function to see like, okay, here's a little bit of scheduling that's happening. Let's see what async does. I think async should be defined here. Okay, so multi-channel sand. We have a task channel. We're just like wrapping that function F, right? Do task step. Try wave effect. We are digging deeper. Cool. So we're gonna be using an atomic, right? To synchronize this work happening here, right? With the value that comes back from a sync. So that later on, when we do await pull left, right? Oh, okay. So my guess is that on the first execution of work, right, this will just deploy all the work, right, by constantly coming into this line, right, over and over and over until the last one doesn't, right? So in other words, this will actually look a little bit more like this, right? Let's say we have 3 cores here, or 3 tasks that need to be executed, right? Yeah, exactly, yeah. So this d plus, I mean, this like dividing by 2 would be doing exactly that, right? Like end start. I guess end will always be the same, it doesn't change. So we need to use the start to figure out what the current end is for the current iteration. But here on the left, I would expect this to execute this way. So the first time you call it, it goes into a sync pool, right? And then this version of work here, right, actually ends up in a sync pool as well. And this one ends up in here, right? And the last one doesn't actually call that, but instead executes this branch of code, right? And of course, all the other ones will execute the same code when they come out by just recursing again. So as soon as the work is done, which should be this one, right? On each one of them, they will just await on the parent. So this one, right, is awaiting, let's say, on 3, and this will be 3, right? And wait, am I in? No, here you go, like that. And then this one will be awaiting on 2, and this one will be awaiting on 1, right? I don't really know what await does yet. This is just function, but I would expect this to execute in this way. And as you say, Kritzkrieg, this will be splitting down the array, right, in halves up to chunk size. And I think chunk size is currently using the number of domains. So I think this is trying to split up the array evenly, quotes. I don't know if that's the right word to use here, right? Across all of the different domains that we have available. And I would expect that domain to be a thread. So yeah. Okay. Quite low level. All right, if we go up one level from here, right, the way that we were using this function with parallel find is to iterate over a range. And that's not quite what we want. So let's see how we use parallel scan. Okay, parallel scan combines intervals. I think this might be more useful. And yet, I think this might not work at all, because these functions, I think, assume the work to be specified up front. So parallel scan does a similar thing. We get the number of elements to scan for. So in our first case will be 1, right? I guess as long as we reuse the pool, we should be able to recursively go there. No worries. Thanks for watching, Crits. You're welcome back. Have a good day. Okay, so we're copying the elements, and I assume this is to send them over somewhere. All right, I think I've read enough. Let's write some code. Let's actually try to build stuff. Cool. I'm gonna go to main, which we have because we already did a Doom init. I think I'm gonna have to. Yeah, I can save this as notes. Let's see, bin ml. Am I gonna need to? Yes. I'm gonna have to install the OCaml language server. Since we installed a new version of OCaml 5.1. Yikes. Okay. building stuff. Can feel quite slow sometimes. And I'm running a pretty beastie machine here. Like, all the cores are being used right now. Alright. One last thing. I think I might need to check my Vim. Oh, cool. Alright, so if I rerun this thing. Nice. Alright, we're back. So what we want to do here is we're going to start with a URL, and I think for this purpose, let's say, what's a website we could crawl? We could just have as an example. Maybe we don't need to have a website at all right now. So let's just say URL google.com. We want to start a pool, right? So we're going to do that. We're going to do domain sleeve, domain, and I think we're going to have to install the domains library, right? So pom install domains lib. Come on, Pom, you can do this. I believe in you. Wait. I think. No, okay, that was good. Oof, defaults. I thought it would default to 5.0. Cool. And the result of the pool running is going to be a single value. So for now, let's just say we don't really care about that. Cool. Where is n coming from here? About that, so we'll just do task, do tear down pool, all of the boilerplate. I think we're gonna have to add this to Dune. Being libraries, domains lib. Cool. Nice pool. So that goes there, and that's it. So far, so good. Cool. So let's actually get our crawling function in place. If you give us a pool, we'll crawl, right? We probably want to also get our root URL, right? And in here, we want to do some work like fetch URL, right? Page. And I think it's yet to be decided whether this is going to be blocking or not. But once we fetch the URL, we want to extract links. So this will be links, extract links from page. And once we have the links, we want to sort of queue more work here. So using a task, what can we do here? Let's see. Task. Oh, right. Sync. I guess this is really what we want, right? So we want to actually do a crawl rec. So we get a pool, and then we'll say fun, right? What do we need here? I need a task. How do we make a task? Oh, just a function? Yeah. A task is a function. Cool. So we want to crawl every one of the links, right? Which means we probably have to do something like extract that and then list map, right? And then we'll get a link, and then for every link we'll just queue all of them as a sync, right? And then we have a list of promises, and then we want to await each one of them. So let's see if task has anything like wait. We have only one. All right. So this is rather naive, right? Like we're just going through the pages, and every time a page runs and we get the links, we queue all of the sublinks for that page. So the top level page is not going to finish, right, until all of the sub pages that it links to are finished, right? So if you have one page that links to 10 pages, then that one page will not be finished until those 10 pages are finished as well. And what I would rather do, I think, is to have sort of these crawlers, right, pull data, pull links, right, from a queue. So wherever you are, you can just queue something and say, oh, queue this URL to be crawled sometime in the future. And once you do that, for all of the links in you being a page, then you're done, right? So each crawling unit just takes care of downloading the page, right, extracting the links, right, and queuing those links for later, and it's done, and we can just actually track that has finished. I'm wondering as well, how are we going to see this work? How not visualize it necessarily as a graph, right? But rather, for example, trace it. So in Erlang, we would have, I don't know, recon trace, for example, or the DBG module. So I'll be able to write a little expression here, right? Trace, I forget how to do this exactly. For example, crawl. So every time the crawl function with 2 arguments gets called, then I want to see the return, for example. And then I'll be able to actually see how this work is happening. It will just get printed out. I guess I could right now just do a printf here as well. The pool I don't care about, but I do care about the root. Cool, so we need fetch URL, which will take a root and or URL, and then it will return something. And we need extract links, which will take a page, and it will extract something from there. These two are essentially going to be implemented with libraries, right? Third-party libraries. Cool. All right, so let's go to OPAM and see what we can find. Fetch. Ooh, nice. So we want HTTP client. What do we have here? Easy curl, friendly wrapper around OCurl. Ooh, we have options. Hyper. Web client with support for a lot of things. And 80. I see LWT here. Okay, so first, I think interesting question, accidental complexity, but still interesting. How do you mix and match, right, domains and promises? Because, for example, if I was writing this in Erlang and I was using a library for making a request, Erlang doesn't have a sync await. It doesn't have promises, right? When you make a call in a process to fetch something from the web, that blocks. And that is okay, because you can have millions of concurrent processes, right? So when that thing is blocking, then that process is blocked, but most of the stuff can still run. So it just gets unscheduled, right? Or put aside. And then eventually that call finishes and that process comes back on, right? But when you look at the code, there is no like, oh, I'm gonna await on this fetch call. There's just the fetch call. And here, when we're saying I'm gonna actually crawl this page, right? I want to fetch the URL. If I want to use a library like Hyper, I need an async runtime, right? I need a promise runtime, something that would actually pull on that promise and get it up and running. Maybe this is just a matter of saying like, all right, the entire application will be running now inside of LWT main. But I just don't know if that runtime, right? My gut tells me this is not going to work. But I don't know if that runtime actually knows how to operate across domains, right? So when we say run pool and we say crawl, and this thing actually fetches, right? It may not be running in the same thread as the LWT runtime is. So, for example, in Rust, when you use something like Tokyo, then you have to specify, if you allow me a second, warp build warp main rs somewhere in here, right? So we have to specify that we want to use a particular flavor of the Tokyo runtime, right? And this has a current thread and I think multi-threaded flavor, where if you have many promises, right, or futures called in Rust, right, it will just execute them across all of the threads. So you effectively get the ability to schedule 1,000 promises and just split them across all of the threads, right? But this is because it's built into Tokyo. So I don't know if LWT supports anything like this, right? We need to look into that. Otherwise, every sort of domain that we create, right, we need to run its own LWT main, which is incidentally something that we also did with Warp in Rust. So we run Tokyo in a single thread, right? But then when we needed to make use of all of the cores of a machine, we actually said, all right, how many cores you got? We're using one already. Okay, n-1, let's spin up n-1 workers, like individual concurrent runtime workers, right? So we can run promises inside of them. Okay, so let's see how that works. LWT domains, OCaml. So we'll search for domains here. Aha! We have some helpers. Core. Where is the helper? $860. See the pull request? Yeah. So this is inside of Unix. Okay, so LODT domain was moved to its own package. But I don't see it. Where is it? Where are you? Okay, makefile, OCaml.org, packages, LODT domain. All right, here we go. Okay, so this is essentially wrapping around the task pool that we saw before. But eventually we say running main and we get an F. What do we do here? Try bind F. So we get a job. What is C here? The channel. So we have this new function called detach that runs the computation f of x in a separate domain in parallel. Okay, so we need to use running main then. Running main can be called from a detached computation to execute in the parent domain. Hey Privan, how's it going? Good, we're just looking into mixing OCaml multicore domains and LWT promises. LUT promises. So we can use some of the existing HTTP libraries to fetch the URL. Cool beans. Oh, wow, but that's... So this running main okay, if I'm understanding this is not what I want, right? This is saying when you detach, right, this will run a computation in a separate domain and give you back a LUT promise, right, that you can listen on and eventually resolve, right? And it'll be resolved when the domain finishes doing the work. But that's not what I want, right? What I want is to be able to, within a domain, right, run a LUT promise. Because otherwise, the single sort of thread becomes the bottleneck of all the promises being executed. And so this feels more like a way to run multiple blocking pieces of code, right, on separate threads, while still keeping them represented as concurrent pieces of data, right, promises. And then running main can be called from a detached computation. So anywhere, right, you can call running main. But this actually blocks the domain that's calling running main until this is completed. So if we have one, let's say 3, right, domains, and the 3 of them start running, and the 3 of them call fetch URL, then it will actually be the first one, right, if we use running main, that will run the calls, right? And the other 2 will just be there idle, right? So I'm wondering, is this the blessed path? Because I was expecting the ability to actually schedule promises across all of the threads, right? And say, oh, you know, this will run here, that will run there, and so on and so forth. What do you think? I feel like I'm missing something here. I think the alternative here would be to just spin up plenty LWT mains, right? One per domain. But then this pool doesn't actually make much sense. Because I don't think I have control over how each domain gets started, right? So if we go back to, where are you? Hyper domain sleeve, right? Task ML. When we do setup pool, so this is spawning the workers, but the worker itself is a function that's defined here. I think it's this one, yeah, there. Domain local await, using, prepare for await while running, run that thing, and it's here. Receive a task, do the thing. Which is not bad, right? But it's not doing what I needed to do. Okay, so you know what? How hard can it be? Module. Async. Actually, async means something here, right? So let's do LWT pool. And we want to be able to set up the pool, so we'll have something like this, right? And we'll need a multi-channel also to be able to send stuff. The one thing that we would want to change here would be, I mean, this has support for multiple name pools, which is maybe not what we want. We would want to run around this entire thing, right? This LWT main run, so that the entire domain is actually running LWT. I think that will be more similar to what we get with Tokyo when we say Tokyo use the multi-threaded flavor. So the promises are everywhere. Now the question here would be, how do we move those promises around, right? Because if you do this, then all of a sudden you have one thread, right, running concurrent code that if it has to schedule more things, may just schedule all of them in the same thread, right? And if you do that, then, well, you may not be using the other threads, right? You do get the parallelism of having n LWT runtimes, right, just doing their thing, but it's not sort of evenly distributed. So I think there's something about how this is working right now to still work that I would have to read a little more on. Yeah. It is not a lot of code, and honestly, like the bulk of it, right? It's here, maybe a little higher up. Step we probably use as well. Do task, yeah. So the helpers below, like parallel for reduce and so on, we don't really care about those right now. Okay, so just so we have an idea of what we're up to here. We need a pool, right? And the pool needs to evaluate down to a single type, which is what we have somewhere here. We will have a pool. Actually, pool data, domain. How do we get the data of the pool out? T. I guess the T is returned by this, right? Right, we get the T out of the task, but the pool is just, we never know what that is. Let's see. I want to move around, and this is in view only. Okay, fine. Let's run. So we're using domain local await using domain local await using, what are you doing here? Prepare for await. Using prepare for await while running registers the given asynchronous trigger mechanism for the current domain, or if the domain has been configured to use schedulers to current systhread for the duration of running the given scheduler. In other words, this sets the implementation of for blocking under the scheduler. So this is a lower level construct. What does prepare for await do? I guess it readies the channel. I love how the promise is just an atomic here. And perform. Wait, is this a... Yeah, this is an effect. Huh. This is cool. All right. So wait, where's wait defined? It's not defined anywhere, so it must be part of effect. Yo, we went too deep here. It was like, oh, let's just scroll some URLs. Now we're looking at, can we make an async pool for LOUT that actually schedules all the promises in all the threads? Ay. Okay, so wait is defined here as a GADT. Cool. That's what I was looking for. And wait, yeah, okay. So the type of the promise, which is the type of the atomic state, that is escaping the GADT. So again, prepare for await. First thing it does, right? I find it, here it is. First thing it does, it just creates an atomic that will say we're still pending, right? And this will be shared. I guess this will actually be shared. Where? Why is this atomic? Why is that not a ref? Like, it would have to be atomic if we're gonna be accessing or mutating that value, right, across multiple threads, right? If it was within a single thread, it could be a ref. And here we just create two functions, release and await, right? And release is trying to get the value from the promise and ask whether if it's returned or raised, then we do nothing, that's the end of it. But if it's pending, then it would actually swap the values, right? Whoa, wait, what does atomic exchange do? Okay, so if it was pending and now it's released, right? Then we swap the value, we put a return in there with a unit. And then we grab the pending, and that pending here is the same one as here, right? And what is this KS? I mean, it's a list, but of what? We get pairs. K must be a continuation. And C is a channel. Okay. All right, so that's release, right? If we release and we have already returned or raised, we do nothing. If we release while we're pending in the current channel, then we're gonna just place a return there. So the next time somebody calls release, we're good. And like the first thing we do. And then for every continuation that is pending, we will send in the channel C a thunk to continue that work. Oof. You know what? I think I'm gonna go into that code. Let's see here. Oh, you're right there. Where is the multi-channel? I literally just opened it. Really? Oh, sorry. Channel, if I can type. Hey Tianyi, how's it going? I guess so. We started, just to do a recap, we started sort of planning out how we would do some of this, right? So we have a root URL, we fetch it, extract links from there, get a collection of URLs, right? We started looking into the domains library, then went into domains lib, right? Which is like a higher level lib for this, right? Which includes task abstraction, which is like a task, like a thread pool. And then once we started scheduling this thing over here, right there, we realized, well, you know, when you do a crawl and you fetch a URL and you extract the links and just put all of those into the pool, right, you actually need to deal with promises, because some of the libraries that you have for fetching URLs and, you know, doing I/O, they are async. So OCaml has been single-threaded for so long, right? So we went into, where was it? We hyper, right? And this library said, all right, you want to run hyper, you need to do hyper.get inside of the LWT main context. So this will actually be a loot promise, right? I say loot, but you know, LWT, it's just lightweight threads. It's too long, so loot. But how can you run the promise if you don't have the async runtime, right? Like domains is not async, it's parallel, right? So we need to figure out how to actually get a runtime, an async runtime, right? That runs nicely with domains. So we found loot domain, which we thought, great, this does exactly what we want, even though there's not a lot of examples here, right? But reading through this, essentially what it does is it allows you to convert a function that runs in a domain into a promise, into a loot promise, right? Or it allows you to run on the main thread of loot, right? Code from any domain. So if you have 1, 2, 3 domains, right? Plus your main thread, any of those domains can say, well, I need to run a promise, so I'm just going to schedule that on the main thread, right? But then it will block that domain, which means if you have to make 3 HTTP calls, they all will be happening asynchronously in the main thread, but the rest of your threads are going to be blocked, which is also not what I want, right? What I want is to be able to say, in any one of the threads I'm running, of the domains I'm running, I'll be able to make a call, right? But asynchronously keep executing work on that thread, right? Which I think is not an unreasonable expectation. So I think that's where we are. So I started digging a little more into how does the task pool work, right? To understand where exactly would we have to hijack this, right? To allow the task pool to actually execute promises internally. So that way you'll be able to say, I have n domains and each one of those domains can execute concurrent code, right? That will be like the first step. And if we get that, then we can say, all right, now we can get those domains to steal promises from each other, right? Or maybe not steal from each other, but rather queue promises on other domains, right? Rather than always on the same domain. That will be like the second thing, I think. So yeah, we're pretty far from just writing the crawler that I really wanted to, but that's a little bit where we are. Thoughts? Yeah, I was just copying some of the sources of the library into the project so I can play around with them, so on. I guess I will also need Chan. Cool. Yeah, that's reasonable. All right, so I'm just gonna close that, and I think we were looking at prepare for await. So I'll just close everything, bankrupt Vim. We want to go into taskml, right? Hopefully we'll get some annotations now, and we do. Perfect. And we were trying to understand when we call prepare for await, right, in the domains local, which gets called several times as far as I understood. What is it that we get back when we get a pending? Which is a promise state, actually. You can see that there. All right, so we get a continuation, and I guess this comes from the domains library, domains deep. Perform is also coming from here, and I guess the effects are an extensible variant. Oh, that's what this T is. This is effect.t. There's a little plus here. Sneaky. So we're adding a new effect that we will do, and this effect is a wait. And the wait includes a promise, which includes a promise state, which is one of all of these things, right? So where does the promise come from? Let's go back to our prepare. Okay. So essentially, if the domain local await calls await, we just perform the wait effect, right? We save the channel and we keep the same promise we had, and that promise is going to be this atomic. And I guess the reason it is an atomic is to make sure that no two people actually get to read or write at the same time. Okay. All right. We're going to do a 30-second pause. I'm going to stretch my legs, get some water, and then we'll be back. All right. So, prepare for a wait. We cover that. What does this return? This returns that little struct, right? Scheduler independent blocking mechanism. I get the impression that there's something there, but I can't see it. The end result is effective interoperability between schedulers and concurrent programming languages. Well, I don't see it yet. Maybe I will at some point. But right now, this is confusing. Domain local await. So worker itself is being used in spawn, and that needs to return a domain T. And this returns, and what's an alpha here? What? while running. So using returns a while running a, right here. Whatever while running returns, that's what it returns, right? Oh, sorry. Spawn returns a domain, but it will take a function that returns domain. So it returns a domain that has an A inside. Okay, that makes sense. Because this worker will actually return a unit, because that's the stuff that we have over here, right? That function worker returns a unit. Takes the channel, but returns a unit. So whatever the work is, it will be a unit to unit, and then we just recurse and receive the next piece of work. Okay, so one thing that would have to change here is that this loop here, right, would not necessarily happen in this order. So essentially, right, we will have F returning a promise of some work, right? And I guess every one of the promises will be scheduled independently. This goes the other way around. But eventually, we want to be able to actually await all of these things. So we're this worker, right? A new piece of work task comes through the channel, right? And we start evaluating it. It may block at some point, that's fine. Actually, my gut tells me that at this point, right, the worker itself will be the one scheduling the work, right? But we will still receive work on every channel. We will still receive work through the channel, right? So every time we receive work through the channel, we need to schedule our work in the current async loop. So that would cover roughly, and there is a big question mark here, right? Also, this actually requires a promise, like a value, to be executed, right? So we'll have to create a promise here that runs the loop, and they just schedule that. So this as it is won't work, right? But that would run the pool. Step, do task. I'm missing this stuff. Let's figure out what this does. So get pull data, we saw that above, right? What does step do? So try with. Okay. So this is for running the effect handler. Okay, so loop is defined here as again. So if we have wait, when we try to step, we will call F with V, right? And we will use the effect handler to handle any effects that pop up. And I guess F here will take an A, so V would be an A. And then what's T here? T will be the effect, cool. An A will be the value. Okay, this is a different A. Is it a different A? So if I do B here, that's fine. Okay, so if that's the error we have, then we're good. Yeah, okay, so these A and B are actually different. So this one would be the result. B would be the result of the computation. Ah, good point. Maybe I'm doing all of this in vain. Let's see. EIO. Nope. EIO OCaml. Effect-based direct style IO for OCaml. Cool. Motivation. This library is a low-forwarding code with either multiple threads of execution, each with their own stack, but the stacks are simulated using the heap. Cool. Nice. Oh, they have tracing. Nice. Yeah, Tianyi, this makes a lot of sense. I think we should try this thing instead. Alright, task. It was fun messing around with you. Go away. And we also have channel. Bye-bye. So we want EIO, install EIO, anything else? EIO, Linux main. What are the packages here? Nope. I want to go to OCaml. What? EIO. Okay, we can start with that. Wait, wasn't there another one? Something like meow? Camel. Yeah. I think this one was another alternative. By Dinosaur. Meow. Run. Call CC. Call CC. I think this one and EIO are actually equivalent. Or, yeah, they achieve the same thing. I don't think it's a scheduler like the Erlang scheduler. I don't think this is preemptive, right? Maybe it is. So suspension and API. Finally proposes the management of the suspension be delegated to the user. Okay, so this is cooperative, right? So not like Erlang, but you know, if we're playing nice to each other, then yeah, it could be like Erlang. But a task can block the process. Hey Mas, I don't think this changes how the GC behaves. It's like one of the nice things about Erlang is that each process, it's kind of its own program, right? So the GC can run only on that process at a time. It doesn't have to stop the entire thread, right? To do GC on all of the processes. But here we don't actually have that kind of granularity. We just say like, okay, we have domains, but it's still the same program. I don't know exactly how the new concurrent/parallel GC works. I would expect it to be a lot smarter than we're gonna stop the entire program, right, to do GC across all of the domains, right, all of the threads. But I don't think it would go as far as Erlang as saying like, oh, here's one specific unit of work. I'm going to GC just that. Okay, you know what? Let's try it. We're gonna go for EIO first, since that's the one that we got out first. EIO. And let's see some examples here. Networking. Pretty low level stuff. TCP, main. Let's see, examples net. So what I want to see is how to make a request. That's all I want, right? So some tracing here. Got flow, whatever that is. So we connect first to this address, right? And net is something that we're passing in. So I guess in main we're gonna see client.run. Where are you? Client run net. And where is net? I don't see net. Okay, sorry. It's here. We get the network out of the environment? How does that work? Okay, so we don't need that anymore. And I think we're not gonna have any of these things. So for the time being, I'll just do that. So EIO, we have a standard env, and we have net. And okay, so this is a resource. Cool. So we access the resources, and the environment is being provided by EIO main, which we don't have. So my guess is that we'll need to do EIO main here, and that's going to complain because we don't actually have that library. Cool, so we have the library now, right? Which means we can actually call that, and let's do main. We're gonna copy a little bit of the pattern there. So, switch here would be used to do what? EIO standard. I guess switch is here, right? Switch. Run. It receives a switch, and I guess on that switch we can do things, right? No, doesn't say anything. There you go. Canonical EIO switch. Many resources in EIO, such as fibers and file handles, require a switch to be provided when they are created. The resource cannot outlive its switch. Okay, so it's like a context. If a function wants to create such resources and was not passed a switch as an argument, it will need to create a switch using something. This doesn't return until all the resources attached to it have been freed. Okay. Any function creating resources that leave it needs to be given a switch by its caller. right? And I guess in this case, when we do run and we get a switch here, right? If we do fiber, actually EIO fiber, and we do fork, this will receive a switch. The switch will still wait for the daemon fiber to finish canceling. So it does seem like an execution context that can keep track of what things are running, so we don't accidentally finish running this function here, right? This one. And start running some other things before we make sure that everything here, all the resources associated with it, have been cleaned. Interesting. So in our case, we don't really want to. Do we want to create a switch for every client run call we make? Okay. So this will solve the problem of how to make a call, right? How to fetch the page. I think that'll be fine. We might be able to get away by using a single switch. I don't know. What I'm still looking for is how do we incorporate something like this, right, with a pool? Because this had fibers, right? And the fibers yield control back. You can cancel fibers, you can erase them. Okay, so we can use the EIO domain manager to run this in a separate domain. Using promises to cache lookups with the twist that another user might ask the cache for the value while it's still adding it. We don't want to start second fetch in that case, so instead we just store promises in the cache, right? Notice that we stored the new promise in the cache immediately. I think this will be relevant because if we have the same URL across two different subtrees, right, of the site that we're crawling, then we want to just hook onto the same promise rather than fetch it again. Streams. I think it's safe to say that there's a lot of lower level primitives for us to use here. worker pool. There you go. A useful pattern is a pool of workers reading from a stream of work items. That's pretty much what we want. Client forwards submit the items to a stream and workers process the items. Cool. So how does this look like? We have run, we get a domain manager, right, from the environment. We create a stream of length 0, I assume, and we spawn workers. So we get a fork daemon, and in there we have the run worker function. Okay, so this is starting to look more like what I expected originally. So yeah, we spawn different workers here. So you will spawn, I guess, 1 worker per domain, right? So per core. And then we have a switch run here for 1, 2, 3. We submit work, and then this should be fine, right? Because we're using the same switch for spinning up everything, which means only the switch will only finish running, right, this whole code once all of the workers have finished running, which means as long as run worker, which is defined here, continues to run, then there will still be a fiber doing some work, which means we'll execute to completion. And run worker here is just taking from the stream. We get a request and a reply. So request, I guess, is the stuff. What is the request reply? Submit. Request. Request is the thing that we submit, right? Submit stream I. And I guess in this case it will be a number. And reply is what we await on, so the promise that we create. But result reply is what eventually gets passed into the run worker function. So when the worker pulls from the stream, it will get the number, in this case the I, right, that we're sort of iterating over here. But we get a function called reply that it can use, or I guess this is right, result reply is not a function, but it's something you can call promise result on. All right. And it will call handle job to simulate some work. So I think this is what I originally envisioned, right? That you'll be able to just say, okay, I'll spin up my workers and I will just have them do some work. So with this in mind, I think that in here, inside of handle job actually, right, we should be able to create a switch, right? Switch run, or potentially even thread the switch around. I don't know if that will work, so that we can get, right? Where is it? Yeah. Yeah, what they're doing here is just create a new switch, right? To connect into the address and actually fetch something. So this is rather low level, like we're writing strings to the server. So this is definitely not HTTP, but I think it will be enough as an example. Okay, so that said, I think we're gonna steal some of this code, right? And try to write out our crawler, right? To run in this worker pool. And in handle job, right, we will actually get to make a call to fetch the URL and then just do the rest of the link extraction and so on. So with that said, let's type. So I want to actually do this here, main main.run, and we'll get an environment here. And I think the first thing we're going to do is just just get the domain manager from EIO. We're going to do standard emp here, right? And we'll do domain manager from emp. We also want to get the network, right? Which we had before. Net from emp, right? And with that in place, we can just say domain and net and just call ourselves with that. Cool. So let main domain net. I think that's everything we need from the environment so far. Cool. And in here we want to create a switch, right? So switch run. switch will actually have a stream, and this will actually call work queue, right? So stream create 0, and then I'm actually gonna just throw a few modules in there. So we want to be able to create one of these folks, right? Type. I don't know if we'll need a type for this, but spawn, right? In this case we don't really care about the name. So as long as you give us a switch, right? Then we should be able to create that, and we'll do fiber fork daemon, and I think I'm gonna need to open EIO standard here for this stuff to just work. Yeah, daemon, so we get the switch there, right? And then we'll have our little function here that is sort of the do run, right? So EIO domain manager, and then we'll do run, and we actually need the domain as well here. And this is a domain function, and this will be our loop, really, right? So the thing that does the work. And here we will pass in the stream, which we don't have. Spawn, so we need the switch, but we also need the work queue, right? And I'm already thinking how I could use something like this, right? To create an OTP style abstraction where each one of these workers is actually a process, quotes, not really a thread process, right? And instead of a work queue, you receive a mailbox. I think it'll be fun to play around with that. Yeah, exactly. Boom. Yeah. Cool. So we get a work queue here, right? I think we don't need anything else. Since the run worker, no, we just need the name. We don't care about that. Yeah, actually, we can just do that. So we'll just do loop, and here we get a work queue. What else? So in our loop, we need to actually pull from that work queue. So we will get a request and a reply, right? So we'll do EO stream take from work queue, and this will be work. Or maybe instead of work queue, we'll say task queue. So we can say that we get a task right out. I think it's nicer to think of a task as a piece, like an entity, a noun, than a work. What's a work? You know what I mean? Yeah, so we'll do result, and this will be handle job, right? Or, yeah, handle task, and then we'll do promise resolve, and then we'll get a reply result, right? And then we just loop again with our task queue. Actually, I don't like that there, so I'll just bring it back in here. Cool. So the last thing we need to actually do is just to let handle task, right? And oh my god, this is like this is a functor already, right? Like if this was the base, it's like, oh, here's how am I gonna handle the task. It's just pass it in from another module, and then you get the whole worker. Fuck it, I'm gonna do that. I think it's gonna be fun to do. I always forget the functor syntax in OCaml though. It just never came natural to me to define. Okay, so it's like a function on the left. So we want to do like a base, right? And yeah, that's it. And then we'll do that. I think that's how. I think we might need a type here, right? Like so worker base. And then we'll do handle task, right? And then this will be some task t, and then we'll in this case just return a unit. We can figure out actually, you know, task result. We can do that, or sorry, val. Cool. All right, so we have our worker there. I think our task queue, will get back to that in a second. So now we can do like our crawler, right? And now it's gonna be a worker of struct, and we can do task. Right now we don't care about that. We'll handle that later, right? So, oh, sorry. Would this compile? Sorry. No, it's fine, it's off. What am I doing? This functor has type. And this is why I don't like functors. So we're gonna do crawler, spawn, domain, task queue. I'm gonna do a switch there, right? Cool, okay, so we get a little error there. What does it say? Parameter cannot be eliminated in the result type. Please bind the argument to a module identifier. Okay, fine. We'll deal with that later. But I'm gonna functorize the crap out of you code. You hear me? Worker spawn. Cool. Nice. That's sort of what we want. I think the network is being passed but not being used somewhere. I guess in worker spawn. Right. So we're gonna need to make that get to our handle task function, right? So this will need a net here, which means this will need a net here, right? Which means this will need a net here, which means this will need a net here. Yeah. And of course, this will need a net, no, there. All right, cool. So we have spawn, and this should return a unit. Is that right? Should I return a unit? Fork daemon, spawn worker. Yeah, it does. Okay. So we just need to figure out how many cores we have and spin up a bunch of this ones, right? So we can do for I to 10. For now, right? Yeah. Honestly, I think it's the same. Like, I would much rather get all of this, like, no, you're doing the wrong thing, right? The moment I type something down, than an hour from now when I haven't forgotten what I've done, right? But it's less fresh. And of course, if it's unfinished work and it's the weekend, right? Then it will be days before I actually get the errors in an untyped language. To be fair, like, I don't necessarily think people will do better work with this. I think it just helps me, and maybe it will help other people as well. But I know people that are amazing at doing like dynamic, systems, and they build just this, I don't know, castles in their mind of how everything works, and it just works very great for them. But it just does not work for me. I don't understand it. Like the ceiling of complexity that I can manage with types is just so much higher, right? Yeah, exactly. I use OCaml because I'm dumb, so it's what it is. All right, so this will spawn workers, and I am making an insane effort not to just change what I am doing and just build that OTP thing, because I really, really want this spawn function to give me back a PID, right? That is really just like a handle to the stream that it created internally, so that other people can use to send messages to this thing. All right, whatever. Moving on. So we have spin up the processes. I think that's it. I think once we do that, that's kind of that. We have the workers. We just need to queue the first URL, right? I don't know how we'll do that yet. We have the task queue. I think we just need to we have the submit function to help us with that, right? And I think we only need to get the stream, right? Yeah. So we'll get a resolve. So we create a promise here, and this is not your regular promise. This is algebraic promise. Cool. And we just add that to the stream. Add stream. We'll do request. This will be URL. So actually, we will do URL. And then resolve. And then we just await for that reply. Hey Privan, how was walking the dog? Muy bien, nice. Muy bueno. Q URL or Q task actually. And here we'll do fetch URL. Well, that sucks. Oh, it's not and it's done? Do done? Damn, I never use iterators like this. Hi, Prophet. How's it going? And what are we missing here? We're missing net. Cool. And this will be worker fetch URL. Main net. Did I mean? All right. Okay. So line what? 37. Expression here that expects net but is not receiving it. And I think that resolve? What? Writing docs is boring. Yeah, I think it depends. I like writing though, but obviously not about anything or everything, right? What are you documenting now? I'm really scared about AI generated stuff. I've watched enough Star Trek to know that holo addiction is a thing. What? Just got here. The vibe is so intense. Someone fart or something. Lamau. Damn. Twitch going across senses. Yeah, I used to work at Klarna. Guess you can call that fintech. Yeah. Oh, the music. Yeah. Let's see. I'm running a playlist by Lo-Fi Girl on Apple Music. This is beats to relax or study to. But yeah, it's kind of intense. It feels like a Dune spin-off. Let's see. Let's go to some synthwave. 1, 2, 3, 4. Cool. Zimbler, cool. Yeah, I'm in Stockholm. Zimbler. Pay, get paid. The universal way to pay and get paid. That's trippy. The moving or the things on the top and the bottom. So I worked at Klarna.com ages ago. It was like 2015 through 2017. It's been a while. Shop och spar. Upptäck det bästa del som reklam. Anyways. So, we have spawned the thing. For some reason, QTask is not doing what I thought it would. This should be the right thing, but for some reason, we create the promise, right? And we add it to the queue. Task resolve. But this is missing a net parameter. I don't get it. Where? How? Loop. Net. Blame 34. So it says main. I'm getting the domain in there. I'm getting the network as well, right? Oh, I'm not Swedish, by the way. Like, I do have a passport, but I'm Argentinian. What are you doing now? So, we are trying to build web crawler in OCaml using multicore OCaml, using a library for I/O called EIO. I think that's how you pronounce it, EIO. It's funny because throughout the stream we started with like, oh, we'll just use domains, which is what OCaml ships with, right? Like a low-level library, and we built up to this. And Lambda Keeps at some point was like, hey, you should try like EIO. And I was like, all right, let's give it a shot. And this is exactly what we were looking for. But also, this is so close to the kind of primitives that you could use to build a runtime like Erlang. I mean, big asterisk on that, right? And Erlang was the language I used at Klarna, which is the company in fintech that, I just mentioned. So why OCaml? It's a beautiful language. It has an amazing type system. It really helps me understand the stuff I'm working with, right? Yeah, you should stick around to see the kind of things that we can do with it. Cool. So, what the hell, man? Like, where is that net parameter missing? Main is being called with the .NET, the net as well there, right? Run is being called with the function. So we do fun here, right? Okay, so at least I can narrow it down to queue task. And this needs a queue, which is a promise. And the task queue, please don't have... Why do you have .NET there? Like .NET, I keep saying .NET. It's just like a net parameter. We do have a task, which is great, right? Oh my God. God damn it. That's where he was. He was missing that thing there. And use the type output. Yeah, that's fair. Yes! Success! It compiled! Average EIO experience. You think it's any better with meow? Yeah! Let's fucking go! Any second now I'm opening another monster. If we reach 1,000 followers, I will drink more caffeinated drinks. That's probably not good for my heart though. That model of streaming. Yeah, anyways. Cool, so we have this thing which is doing more or less what we wanted it to do, right? So now we actually get to do some of the crawling. Yeah. I really like the capability model, right? I think it makes sense, but it also, fuck, it gets so much in the way, you know what I mean? What I was considering as I was threading in all this stuff is just, I will just make a context, right? And that context will have the capabilities that this program, the entire program needs, right? So then I could just pass in this one thing, or even make it global, right? Which probably global is a bad idea. But at least you would have a chance at some point to say like, do we have these capabilities, yes or no? Yeah. I don't know. Let's make some requests, shall we? Cool. So now that we have this, we want to do OCaml EIO HTTP. Let's see what we find. Oh yeah, 100%. This is very low level. Like I would not write an application in this sort of style. To me, like I need abstractions. Give me a process, right? Give me a mailbox, something I can just say, well, I'll just pin these things and I don't care how they run. I know they will run and I will just receive the messages in the right order and I will build with that, right? I am though burdened by having worked with Erlang, right? I am hope. What does it stand for? HTTP, OCaml, Pascal, no, Postgres, and Erlang. Well, we know that the E is for Erlang, so I'm happy with that. All right, so how do we do? HTTP clients. You mentioned Lambda keeps. You mentioned EIO LWT, right? Which I think we could probably just shove in here, right? Because if we have LWT, then we have Hyper, and that's good. But let's see, Hyper actually has an EIO version. I don't think so. No, this is very tied to that. OCaml.org. I think in the Learn we had a link. EIO LWT. Yeah, that's what I searched for, but I got the other one. I wanted to check this link. Is OCaml web yet, right? HTTP clients. There's a category for this stuff. Ooh, there's so much stuff in here. Red. I don't think that's good. Yeah, this took me to the library that I had on screen a second ago. Okay, so it looks like we can just wrap everything in this stuff. With event loop, and we have to pass a clock from the environment, and then we just do run LWT, and this sort seems to be just regular LWT code. How far would that go, though? Because I get wrapping the runtime like that, but would I be able to run async stuff in here? Because we have these promises, right, which are from the domains in each one of the fibers. Okay, let's do some reading, shall we? The T engine that uses the IO, it can be used to run in a single domain. So no. Parting. Fuck. This is the same problem we had before. Like, my gut tells me we're not gonna find what we want here. We're using EIO event loop instead of normal LWT1. Everything else stays the same. Okay, maybe we'll be able to just run this exactly where we need to do the IO, right? Call hyper, and that would be okay. You know what? I'm gonna try that. We'll see how far we go there. Cool. So EIO with event loop, right? And we need a clock. So let's do. Cool. So we want LWT-IO, LWT. Installing. I feel very hacker man with this music. I just wish I had a mustache alone. Nothing else. does. They do. That is pretty amazing. Oh, yes. Yes, please. This is exactly what we want. All right. LUT, thank you so much, but no. Cool. So we don't have to do any of this stuff. Oh, but we need to thread the entire environment? Are you serious? I don't know, actually. Maybe. But then again, it is pretty slow. Considering how fast Dune is, right? And, I have a pretty decent internet connection here. It feels very slow. Okay. What is the type of this thing? You're not gonna tell me, are you? Syntax error? Where? Just build. Damn it. Oof. Right, fine. So all right, we're good. We have everything we need. We can do let open co HTTP EIO. So I don't think it's gonna work. Client get env, right? And then we can do. We just have one task here, so. That's the package. Yeah, like this stuff is usually really slow. Like I would get why doing cargo install, right? Or cargo build on a large Rust repository would take a while. and it does, right? But here, especially since I see a bunch of cached stuff, I don't get it. Could be a cache locality thing. Could be that I'm just downloading from really, really far away, like another planet or something. What do you mean? See, like with the dash? Yeah, okay. This is also something else that just really bugs me. Sometimes it's a dot, sometimes it's a dash, sometimes an underscore. Just gotta try it out. You can read the docs as well. Programming languages. If I recall, I got myself a copy of this book over here. Boom. Types and programming languages. And I just started, and I never stopped. Well, that's a lie. I did stop a little bit there, here and there. Cool. So what we want to do essentially, just let result. I'm gonna do host. Oh, we need to split the host and stuff. No, I don't want that. What is this? Flow two-way? What are you doing to me? Get. Body disallowed call. Alright, so that's a function. Oh my god. Okay, host. And then host again? I don't think that's what they mean. No, what? Computer, behave. Okay, and then we get a response. Cool. Fuck it. So that will be the result, right? And I guess clear client read fixed. What does read fixed do here? Rechunked. That'll be good, but no. Fix, we just get everything into. Alright, cool. So this would be body. And now we need something like lambda soup, right? No, what am I doing? Go back. Lambda soup. To parse this thing. And do stuff with it. Perfect. So palm install lambda soup. Yes. I think what's funny is that while I use OCaml a lot and I sketch a lot of ideas and things in it, right? I normally work in a subset of the language where I don't do any IO, right? I'm just working with like abstract data. So types, really, right? ASTs, transformations, and all these things. And there are side effects, of course, there's like hash tables and mutability and all these things, right? But usually, for example, when I was working on OCaml, like if you look at the source, especially the source of like the sugarcane version of this compiler, like most of what's inside of a new comp, like all of this code, right, is just operating on data inside of OCaml, right? So the edges, how to read from a file, right, how to write something down or read from like the network and so on, that stuff I'm usually rusty at, right? It's like once you leave the data into OCaml, I'm good. I can do my thing, right? So if what you're gonna do looks a lot like, oh, just, recursive transformations over some data that you own, then OCaml is pretty fantastic for that. We need lambda soup here. Cool. So now that we have that, we can do lambda soup, and I guess there's a parse function somewhere. And what do we get? Buddy. So notes. Yeah, you know what? Print string buddy. I think that'll be fine for now. And of course, we don't need the network for this. So I'm confused. What do you want? You want a body, this not call. I wish you would just show me the signature there. House is a string. You want a string. All right. So this should do stuff. Yes! Woo! Look at that! We got HTML. I think I can do color here. Yes. I mean, it's moved and whatever, but you know. So now we just need to, I think it'll be good to first to follow the redirects. And after that, use the soup library to actually get all the links. But I don't know if it will be very interesting to use google.com here, so let's actually use something else. Like, we can use this. And over here, we're gonna do fetch, and we'll do host, string, path, string, right? So we can do fetch. Host is gonna be github.com, right? And then path is gonna be most of that stuff. So fetch, we get host and path. What? In a file? What the hell? How do I get the, maybe the response has contents? Really? No, that doesn't make sense. Okay, that makes more sense. Except that this thing is a response. Status D. And no, I think we're gonna need to do client response. 301 as well. How do we change that? Fetch. This is gonna take a bit. Cache, 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 cache. Everything's cached. So what are you actually doing? So we want to start passing some more options to this client function here, get. And I think one of the options will be headers, right? And this will be a header T. So it needs to be header. Oh, please, we can do that. Let's go back. So coxdp, right? We want to do follow redirects there. Follow redirects. Maybe that's not something we need to pass in. Follow redirects, Mike's redirects. We have an example here. That's good. No, I have to build this. OCaml, I love you, but why do you do this to me? So in the status, we'll get a 301 or something, right? Huh, interesting. All right, so we're gonna make a function here called fetch. Right? And we'll receive our little task. And we will call it fetch, and we'll get a body back. And inside there, we're going to put all of this redirect stuff. Recursive, and once we get that back, we will get a status. So status, right? So we're gonna match your status with if it's an OK. Excellent, right? We can go ahead and actually read the entire buffer. guess this is the line that they say, well, this is actually gonna leak memory. Or we let starring there. It doesn't really say. Okay, you know what? I'm gonna risk it. However, if we do get a permanent redirect, right? Or we get a move permanently. Or we get a temporary redirect, or we get a found. Then we're gonna actually just recurse there. So fetch, right? Where do we get the new URI from there? Here. Look at the location. And right now, I don't actually care much about that case, so we're actually gonna do a get. So we will have a location. But the location, what will it be like? I think I will need to use a URI, parse that thing, get the host and the path separately, and that'll be that. Cool. Alright, so host, path. Do I have a URI module already? URI, I do. Okay. So maybe I can just fetch and say URIT. Yeah, absolutely. As soon as I'm done with this, I'll just push it. Oh, actually, let me just do it right now, so I don't forget. Dribble, I think it was called something like that. Public. Cool. Commit boot. And we're gonna do that. Cool. So all the code should be here. I'll drop that on the stream link. I cannot paste stuff here. Terrible experience. Triple. Main. All the code is in the main file, so that should be straightforward to work with. What? Path? Oh yeah, this always works. Right. stuff anymore. We just need to call URI of string, right? And then we can put all this together. What? I guess this one didn't work. Get. Oh man, I wish they would let us do like get or panic, so you can just quickly write a string here saying like, oh, no location is missing, for example, right? So I will have to do the switch here. So location, destruct that thing. If it's none, if it's some, then we'll get a location, and then we'll just do this thing, right? But if it's none, then we'll just do fail with could not redirect without a location. And I think I'm gonna need to brace that. Cool, run. And it didn't even get there, what? Oh, you do that. printf, redirecting to, right? The weight. So this is doing something. What is it doing? Huh, we're not even fetching? What is this? Oh, it was. I think I might need to flush that buffer. Why are we getting all those redirects? There you go, that makes more sense. Fetching, redirected to same fucking thing. I'm actually gonna print here the status. Because I think one of them is found, and we should be handling that as a redirect. I think. Okay, let's have a look. So HTTP status, right? To string, and we'll do status like that. No, move permanently. permanently. We get a URL. So if it's different, then we do that. Else we do some, right? So why would we be getting a 301 constantly? Let's see what happens if we curl this. That works. Good stuff. No, we're getting JSON? What? Damn it, just show me the tools. Inspect. Network, closest thing. We're gonna borrow the user agent from here. Nope. So the user agent isn't the thing. We just get a 301. What happens if we open this thing instead? Same. Open Resty? So from what I'm reading here, and help me understand if this is the right thing to do, right? If we are permanent redirect or move permanently, and if we're found or temporary redirect, right? We're gonna go into handle redirect. And these are the same except that with permanent flag is, set to true or false. And here we just cover first for too many redirections in case like this just starts looping like crazy. We get the response headers, right? And from the headers we find the location. And if we have no location, then we just complain, fail with, which we're also doing here in a less fancy way. Just fail with. If we do have a location, then that URL, right, we're gonna parse it into a URI and then call get and follow again, which is that one over there, this one. And reduce the number of redirects by 1. So eventually this will reach 0 and be like, oh, you've done this too much. Not the same flow, but very similar, right? Like we get a fetch URI, right? We extract the host path, add some headers, make the call. If the status is some of the redirects, then we just get the location. If we have a location and it's different than the one that we currently asked for, right? Because then otherwise we would make the same request again. Then we just, if it is different, then we request it. Else, we just try to read the body. And if we don't have a location, then we just fail. For everything else, we're just gonna read the body right now. This is not the right way of handling it, but we just want to get past this. Yeah. Well, it looks like maybe this APIs don't like it, but I don't get why other things wouldn't behave that way. So I have this website, Tiny SaaS Dev, which is super tiny, right? Just like a little HTML. Look at that, right? What happens if we try to fetch that? Permanent redirect. To what? To where? I don't have any redirect set up there. We just get a 200 back. File descriptor used after calling close. Permanent redirect. Eventually we get the same location. I don't get it. Maybe the problem is that this is not doing what I think it should be doing. So let's do that. And let's see. Yeah, we can remove that. No, that looks about as I thought it was gonna look. What is the problem here? I don't think it's a user agent problem. Y'all got any ideas? Alright, maybe I need to take a break. I can't really see the bug right now, but there is a bug right there, and it's staring back at me. I guarantee you that. Okay, well, we'll do that. We'll just take a break. It's been 3.5 hours streaming. I think it's reasonable to take a break now. And the code so far, it's in this repo called Tribble. I left the link over there. Yeah. I might come back later tonight. Just need to eat something first. Okay, folks. Thank you so much for your time. And, try OCaml. Be cool. Whatever.